Hi, welcome back to our lecture. And let's do a little bit of hands-on work with Fargate because really the best way to learn and understand Fargate is to build something with it. In the lecture notes, I have two different stacks that you can launch. One is what I'm calling a basic Fargate cluster, a basic stack, which is this one. And then I also have a more advanced Fargate cluster stack, which offers greater resiliency. This first stack only launches a single container, whereas the second stack will launch multiple containers, and it will actually also launch a load balancer to distribute requests across a set of containers. Now, I've already gone ahead and launched both stacks into my account. So I have a basic stack and then I have a high availability stack. Let's take a look at the basic stack first, just so you have kind of an understanding of what's going on there. And if I open up my editor here, look at the basic template. We're launching creating a VPC environment, just like sort of almost every other stack that we've launched in this course. We have our VPC. We have two public subnets that are set up within the VPC. We have a web server security group, which is allowing port 5000 in from anywhere on the internet. The container that I launched is running a web application, and it's actually listening on port 5000. And so that's why this web server security group is set up to allow 5000. We have an internet gateway, of course, if we want our Fargate containers to be able to communicate out to the internet, they have to have, there has to be an internet gateway configured on the VPC. We have our routing tables set up, and this is our standard public subnets that are routing out to the internet through the internet gateway. This is all kind of standard stuff that you've seen many, many times before in this course. And now we get to our first ECS resource, which is a cluster resource. So we're creating a cluster. The logical name of the cluster is Pets Cluster, in which you'll see why here in a little bit, why it's called Pets Cluster. And all we need to do in this case is just give it a type, AWS ECS Cluster. Our next ECS resource is a web service. Here we are defining the service. So the service has a number of properties. We have to associate the service with a particular cluster. We're referencing the pets cluster that we created above. We have a desired count of 1. We're only going to run one task as part of this cluster. We have a launch type of Fargate because we want to use the managed Fargate compute infrastructure. We have a task definition, which is the web definition, which we'll look at here shortly. Then the network configuration. We are going to assign each task a public IP address. The tasks are associated with the web server security group, which you saw earlier. And the tasks can run in public subnet 1 or public subnet 2. Now, since we're only running one task, then ECS is going to launch it in either public subnet 1 or public subnet 2. It doesn't really matter in this case. Then the next resource is our web definition. So this resource is our task definition. And here is where we are describing the container a set of containers that we want to run as part of this task. In this case, there's only one container that we are defining. The task is going to be given a quarter virtual CPU. That's what 256 means. It's going to have half a gig of memory. It's going to use the standard AWS VPC networking mode. That's the networking mode which we must use for Fargate. We are specifying that the container must be compatible with the Fargate environment. This is all sort of boilerplate stuff that every single time you use Fargate, you just got to include and define these particular properties. We have a task role, an execution role that we are associating with the task, and we'll take a look at that here in a little bit. And then we have the container definition, and the container definition is called PetsWeb, and it's going to launch a Docker image it's located on Docker Hub called Docker-Pets, and it's launching version 1.0 or the tagged 1.0 version. We have a port mapping, so we are going to essentially expose port 5000 on that container, and we're using the standard AWS log driver. That meaning that we are going to log out the logs from the container to CloudWatch logs, and we're specifying the name of the CloudWatch groups that the logs are going to end up in. And here's that ECS task role. The task role is basically saying that the container can be managed by ECS, essentially. We have the execution role, and the execution role is saying that the container is able to write out log information to CloudWatch logs. You see this, it's allowing these actions. So it can create a log stream and log groups and so on. Don't get too caught up with these roles. These are pretty much sort of boilerplate roles standard roles that you'll see most of these Fargate containers using. Okay, well, let's take a look then at the service that was set up, this Fargate cluster. If I go to basic and if I look in outputs, you'll notice there's really no output information from the stack. So let's go into the ECS dashboard and look and see what was set up for us. If I go to ECS, I can look at the clusters that are running. And so we have our cluster here, the basic pets cluster that was set up by our basic stack. And it shows us that cluster is running within Fargate. It's running one service and one task. If I click on that cluster, I can kind of drill down further. One of the things with Fargate and with ECS I've found in general is that it can be a little bit confusing at first to sort of like drill into these different components. Again, because there are multiple abstraction layers, and it can get a little bit confusing at first, but once you work with it for a while, you'll get the hang of it. So we're looking at the cluster, and here we can see the services which are configured. There is one service called Basic Web Service that is running, and you can see that there's a desired number of tasks, which is 1, and there's one task which is running, and these tasks were launched into Fargate. If I click on tasks, then I can see the tasks that are running, and you can see that the task has an identifier here. And if I click on that task, I kind of drill down on that particular task, I can see some information about that task. It was launched in Fargate. I can see the task role, the fact that it's running when it was created, some network information, and then the containers that are a part of this task. And there's only one container here. If I expand that container, then it will show me some information about how that container is configured. You know, there's not much to this particular container definition. If I wanted to look at logs, I could say view logs in CloudWatch to look at the logs for the container. The thing I'm looking for though here is the public IP. Remember that we can treat containers in Fargate kind of like EC2 instances in a way. And so each container is going to have an elastic network interface. So every container will at least have a private IP. And because the stack configured it to also have a public IP, we can access this container now via the public IP because I associated it with a security group, which is allowing access from the internet. The thing I have to remember is that I'm not accessing it on port 80. I have to access it on port 5000. And so when I do that, it pulls up my web application, which is Docker Pets as a Service. And it gives us this little animated, picture of a pet. And it shows me the container, which is serving this particular request. If I click on the serve another pet button here, then it'll pull up a different animated GIF to display. So this is all being, you notice as I like click on serve another pet, it's all being processed by the same container. So that's the basic stack for you. Now let's take a look at the second stack, the more advanced stack, the highly available one. If I go to the editor, I can pull up that template. This template has many things in common with the basic template, but I'll point out some of the differences. Again, we have all the basic VPC resources that are pretty much configured the same way. Here, though, we are introducing another security group, and a security group for an application load balancer. We're allowing port 80 from anywhere to connect to our application load balancer. And then the application load balancer can communicate with the web service on port 5000 because our web service is listening on port 5000. So you have some additional information there that we're setting up for security groups. We also have a second service that we're running. We're running a web service. We're going to run multiple web server containers, but we're also running a database service because we now want to be able to persist some information. And therefore, I have a database security group. And so this database security group is allowing requests coming in on port 8500. And it's going to allow requests on port 8500 from the tasks that are running in the web service group. Notice, by the way, as well, that I'm defining not only ingress security groups rules, but I'm also defining egress security group rules as well. So this is a little bit more complex than some of the security group configurations that we've seen in the past because we're looking at egress rules as well. We have our internet gateway and we have our public routes. Everything is set up the same as the previous template. And now we come down to our ECS configuration. Once again, we have a cluster that we have defined called with a logical name of Pets Cluster. We have our web service, and our web service is running, it has a desired count of 2. So it's going to run 2 tasks. And so it's going to run 2 of the web definition tasks within the cluster. The other addition to the service configuration is the association with a load balancer. We have a load balancer with a target group that we are referencing. And what we're telling the load balancer is that it should distribute requests to port 5000 to any tasks that are associated with this web service. We have the web definition. This is defining the task that is going to be running as part of the web service, and very similar to the previous stack, where you can see the task role, same amount of CPU and memory. Network mode is AWS VPC because we're running in Fargate. We're running that same Docker-pets image, and we're exposing port 5000 on that container. Again, we're logging to AWS logs. Here's something interesting, and we will probably come back to this in a little bit, but we are also passing in an environment variable to the containers. And we are setting an environment variable called db, the value of which is db.service.pets. What we'll learn here in a little bit is that this db.service.pets is actually like an internal DNS record. And it's a DNS record, a Route 53 record, which is being managed by CloudMap. And it will, this record will point to the IP address of the database task. Very, very cool. That's part of this service discovery mechanism that is in place. So that defines everything associated with that web service. We have the web service, and then we have the task that is associated with the web service. Now we're defining the database service. The database service, again, is going to be using the same cluster. We're only running one task within the database service, a Fargate. It's running, of course, in Fargate. And here we're doing something interesting. We are using this service registries property, and what we're essentially doing here is we are telling Fargate to register the tasks in this service, to register it with this database service discovery resource. And you'll see that in a little bit. But this is what is sort of tying the database task to this particular record, this db.service.pets record. That's the service discovery mechanism. Remember, I talked about how you can launch a service and then the service will register itself with a service discovery platform like CloudMap, and then other services will know how to find the service which registered it itself. We have the task definition, which is the database definition. We have all the network configuration, which in this case we have the database security group, and same subnets as the other service was using. Next, we have the database definition. This is the task definition for the database container. And like the other task definition, most everything is the same. The container definition is a little bit different. Here we are using console, HashiCorp console, as our database. Console is a key value store, so we can use it like a database. And we're exposing port 8500 on that container. Once again, we are also logging the container logs to CloudWatch logs as well. We have our task roles that are set up, and these are, I think, pretty much identical to what we saw in the previous template. Next, we have our application load balancer, and by now you should be pretty familiar with configuring and building load balancers using CloudFormation. We have our load balancer resource that we've defined, and we are associating it with both those public subnet 1 and public subnet 2. we have our listener resource here. It's listening on port 80. And we have our target group. We have a health check set up. So there's an actual health check path that the load balancer is going to use that health check path just like it, with a Fargate container, the same way it does with the EC2 instance. We have and it's the target group is forwarding requests to port 5000 because that's the port that is exposed on the web server containers. And then the final resources here are configuring the service discovery mechanism. We're configuring Cloud Map. And this is what kind of ties the web server containers to the database container. Because the question is, like, if you were to launch the web server containers, how would the web server containers find the database container? How do they know, what the database server endpoint is, the IP address is? And we use a service discovery mechanism to do that. The first thing that we do is we set up a service discovery namespace. So you see we're using this AWS Service Discovery Private DNS namespace resource. And here's where we define a namespace. I'm calling it service.pets. You can think of this as being like an internal domain name, which is only available to your application running within the VPC. And then next, we define a service discovery service. Remember when I earlier in the lecture, I talked a little bit about Cloud Map, and I talked about how you can set up a service definition within Cloud Map. And so that's what this is. It's a service definition. And we are defining a service called DB. And that's what's setting up, that's what's creating this db.service.pets DNS record. And what we're saying is that we want to set up a DNS record for this DB service. And it's going to be an address record. We're not using any sort of custom health check in this case. And then finally, we have an output. And the output is the application load balancer endpoint address. So let's go back to our stack and we will take a look at the high availability stack that I spun up and look at outputs. And we'll see that there is an application load balancer output. If I copy that and paste it into my browser, then once again, I get my Docker pets as a service. But in this case, we're persisting some information. So you can see it says 1 pets served. I can say serve another pet. Now it says 2 pets served, 3 pets served, and so on. Serve another pet. So it's persisting this information. It's persisting the number of times that I've served a pet on the system. And you also see that the container ID is also changing. So the load balancer is distributing my request to a different container on subsequent requests. I can also change the type of pet I want to use. So I can provide my name and say my name is Jason and I like whales. When I really do like whales. I'm a big scuba diver and I love everything underwater. And so I can serve up a set of whales. That's kind of a funny looking whale in that case. So this is, again, persisting my information. it's distributing the requests across a set of containers. Now, and I'll let you go and play with that for a little while in your own. It's a fun little application. I didn't write it. I saw this application a couple years ago, and I converted it so that it would run properly within Fargate, because I think it's a fun demo. If I go back to the ECS dashboard and click on clusters, I can then pull up the second cluster that was created. And let's see. There we go. So we have our high availability cluster. You can see it's running 2 services and 3 tasks, because my web server service is running 2 tasks. Each task has a container, a web server, web application container. If I click on that cluster, you can see here are my 2 services that are running. The database service, the web service. The web service is running 2 tasks. The database service is running 1 task. I click on my web server service, and I click on tasks. Then you can see that here are my 2 tasks they're both running. If I click on the events link, then I can see some events that are associated. These are lifecycle events. And if you are ever in a position where you need to sort of troubleshoot maybe some problems with your container, you would want to look at the events to try to understand maybe what's going on, especially if the container is starting up and then it's failing right away. Because Fargate will try to restart that container over again, and it might get in this sort of cycle where it's starting up and then it's dying and it's starting up again. I clicked on the log link, and so here I can look at the logs that are being generated within the container. And you can see here a bunch of like health checks that are coming from my Elastic Load Balancer. Here's one of the requests that came from me to that vote endpoint. So you can look at all the log information. It shows me that when the web container started and that it's listening on a particular port. If you're trying to troubleshoot what's going on with your containers, you can look at the logs and you can look at the events. Those are probably 2 good places to take a look at. Well, I hope you enjoyed this hands-on segment and enjoyed learning a little bit more about Fargate. You'll have the opportunity via a project to work a little bit with Fargate and it kind of expand on one of the stacks that you see here. But I use Fargate quite a bit in the workplace, and I think it's an exceptional way to run Docker containers within AWS. So I hope you enjoyed this hands-on demonstration.